This is an overview and a deep dive into how we solve distance off second bearing problems. This problem behind me is practice problem 5. There's a video solution for this. And the problem gives us a bunch of information. So we read it and we record the information. It gives us course speed, time 1, bearing 1, time 2, bearing 2, and asks us, what's the distance off the second bearing? And so there's a table in the boutage. Table 18 describes the distance from the second bearing given the change between course and bearing 1 and course and bearing 2. So we calculate this and we can get into that table. I'm going to show you this table right now, give you a tour. The top of this table, these numbers up here, see this? This is the difference between the course and the first bearing. We calculated it as 57. So we're going to be right between 56 and 58. We'll be right in here. And then you'll see there's two columns. Column 1, column 2. Column 1, column 2. Column 1 represents distance off second bearing. So that's the column we're going to use. Column 2 represents distance when a beam of that object. So we're always going to be using column 1 in these. And then over here down the side, look at this. Distance between the course and second bearing. So we found that, and these values down here represent the course between the difference between the course and the second bearing. So we can run down these, run down the column and run it over, and we can get these values and then record these values, and they're right up here in this problem. So now we take all those values and divide them by 4. We're finding an average. We're interpolating. It's a weird word, but what it means is we're adding information to that table that's not there. We're finding an average of all these numbers is what we're doing. And in this case, it came to 1.208. But numbers aside, that table value times the distance we traveled between taking these bearings will equal the distance off the second bearing. And so we need to find this distance, right? And we'll get back to what this table does at the end. This distance is speed times time. We use our little diagram, say distance is speed times time. And we're given a speed, but we need to find a time. We're given 2 times, time 1 and time 2, so we can find a time. So down here we say change in time, time 2 minus time 1. We do the subtraction. It comes to 27 minutes, but the minutes, they can't go into this equation because speed is nautical miles per hour. So what we times it by has to be in hours as well. So we take this 27 minutes, divide it by 60, and it spits out a time in hours. Now we can take our time in hours, put it into our equation, and get a distance, right? And we're always going to be rounding to 3 decimal places to get these spot on. Now we take our distance, and we can say our table value here times the distance equals the distance off second bearing. So we took our table value times the distance, and we got the distance off the second bearing. But one question remains. What is that table doing? Like, what is the magic behind this table? What is this value right here? What is all that? Let's take a look. It's just that table has solved a whole bunch of triangles, both oblique triangles and right triangles. The oblique triangle solutions are your distance off second bearing in that first column, and your second column is right triangles that were solved. That's why it's distance of beam. That makes a right triangle when you're a beam. Let's draw this out. Our course was 167. 168 would be straight down. So 167 is something like that. And now we took 2 bearings, right? We were cruising down this thing and we took a couple bearings. The first bearing was 224, somewhere along these lines. The second bearing was 268. It was almost out horizontally, right? Okay, there's our object. And what we have now is all of these angles, right? We said the course minus the bearing was 57 degrees. So this angle right here, we now know it's 57 degrees. And then we solved course and bearing 2, 101 degrees. It actually gave us this angle. But if we know this angle, there's 180 degrees in a line. That means we can get this angle easily. By doing 180 minus 101, it'll give us this angle. And it turns out there's 180 degrees in a triangle. So if we have these two angles, we can get this angle. Now that we have every angle, we're given the information to get a distance, right? We got this distance, which was 8.775. That is this distance right here. Now we have an angle across from a distance. And it stays in the same ratio as the other sides and angles. So if we have this angle and this distance, we can get the distance across from this angle, which this distance is the one we're looking for. This is the distance off the second bearing. So it's just, this table is doing a bunch of math. I'm pretty sure it's using the law of sines, correct me if I'm wrong, to get this distance. And that's the magic of this table. And that's a deep dive and an overview into how we solve distance off second bearing problems using practice problem 5 as our example.